Okay, Algebra AB, we are going to continue solving equations here with Mr. Johnson. And what I want to draw your attention to is the types of equations with variables on both sides. When you see variables on both sides of that equals sign, that means we have a little bit of work to do before we can do any backtracking. All right, so the key point here is that backtracking does not work when you have variables on both sides. All right. So what we need to do is we need to figure out how can we get the variables onto one side of the equation. And that is point number one of our goal. All right. Our first goal is always to isolate the variable. So isolate or get the variable on one side. Get the variable on one side. All right. So we want to isolate the variable. So I need to think about how can I get all of the x's on one side of this equation. The other thing we want to keep in mind is to do our best to keep x positive. All right, if we get into negative numbers with x, it's okay. It's just not as nice to work with. So we would prefer to keep the x term positive. So if I look at this equation, I think of it kind of like a balance beam. Some people like to actually or a balance scale, I should say. Some people like to put a line down the middle and kind of balance the left side with the right side. Anything I do over here on the left, I also need to do over here on the right. So if I think about this as a balance scale, right now I have 5 x's on the left side, and I only have 2 on the right side. So what I can do is I can remove the 2 x's on the right side. But if I do that on the right, I also have to do it on the left. So my goal is to subtract 2 x's from both sides. This will get rid of the variable on the right and keep the rest of the x's on the left side. So I'm going to show that using basic moves. Subtract 2x on both sides. All right, I'm isolating the variable. I'm getting it on one side first. Now, 5x's minus 2x's is 3x's. I didn't really touch that -7, so it's still there. And on the right side of the equal sign, 2x minus 2x, there's no more x's on the right side. I'm just left with a positive 5. At this point, I can backtrack or continue with basic moves because you'll notice the variable is only on the left side of the equation. All right, so we can backtrack or basic moves. I'm going to use basic moves because I think it's a little bit quicker, and a lot of us are starting to get into that. So I'm going to add 7 on both sides. I get that 3x is equal to 12. Divide everything by 3, and x is equal to 4. All right, a reminder, you can always check your answer by substituting that value back in for your variable. So 5 times 4 minus 7, is that equal to 2 times 4 plus 5? I'm just going to put the 4 in there. So let's see, 5 times 4 is 20 minus 7. Is that equal to 8 plus 5? I think 13 equals 13. Yes, it is. So I know that x equals 4 is the correct answer. All right, we're going to try 2 more. And again, those major points. Get the variable on one side and keep x positive if we can. So second equation here, you can pause and copy this down. I notice I've got -3x plus 4 on the left side. On the right side, I've kind of got a bit of a mess. So I'm going to say, let's go ahead and simplify before doing any of those basic moves. Sometimes we have to simplify first, and then our first major basic move will be to get x on one side. So the left side doesn't change at all. But on the right here, if I simplify this, I'm going to distribute that 4. I'm looking at 4x plus 20 minus 2. Let's call that 4x plus 18 on the left, -3x plus 4 on the right. All right, so I've got this balanced equation. I want to get all my x's on one side. I've got -3 of them on the left, 4 of them on the right. I could subtract 4 x's to bring them all over here, but then they would be negative. So instead, why don't I add 3 x's to both sides? This will get rid of them on the left side, and I'll only be left with a 4 there. And then on the right side, I now have 7 x's plus 18. All right, x term is positive. It's on one side. That's what I want. I can continue solving by backtracking your basic moves. We're going to subtract 18 here on both sides, and I get -14 is equal to 7x. divide now by 7, and I get x equals -2. Again, you can check by substituting that variable back into the original equation wherever you see an x. Last equation here, go ahead and pause if you want and write that down. 7 minus 2x equals -6x. So remember, we want to simplify if we have to. Nothing to simplify here. The next thing we want to do is make sure to isolate the variable, ideally trying to keep it positive. Well, here, if I try and keep x positive by adding 6x on both sides, what I end up with is 7 plus -2 plus 6x is 4x equals 0. Now here that confuses some people sometimes. There's still 0 on the right there, but now I've got to get the numbers on the opposite side of the variable. So I would have to subtract 7 from both sides here, and I'd have 4x equals -7. Divide everything by 4, and I get x equals, and this is okay, a fraction, -7/4. Now, what if, instead of really trying to keep the x term positive, I really just focus on getting it on the opposite side of the constants or the numbers? So what if my first move was just to add 2x to both sides? Now I've got 7, those terms cancel there, equals -4x. You'll see this is basically the same spot as I was right here. All right, we didn't change much, but we did it in one step versus 2 steps on the left. So yes, we want to keep that variable positive if we can, but sometimes it's just easier to get the x on one side, opposite side of the number, and go from there. Notice the -4s with the x here. We had a -7 as a constant on the left side, but either way, that still gives us -7/4. You can call that -7/4 like that, or even 7/4. All of those are the exact same number for x. All right, and that is it. That is solving with basic moves with variables on both sides of the equation.